Ever wondered why we are running out of IP addresses? Well, let's unravel this mystery together. IP addresses are like the street addresses of the internet. They are unique identifiers that enable computers to find each other in the vast digital universe. Now, imagine if we ran out of street addresses. Sounds chaotic, right? That's precisely the predicament we're facing with IP addresses. You see, the current system, known as IPv4, is like an old city map. It was designed in a time when the internet was just a tiny town, and nobody dreamt it would evolve into the bustling metropolis it is today. But with only about 4 billion possible combinations, we're quickly running out of street addresses in this digital city. So the question is, how did we end up with this shortage? Stay tuned as we explore the history of IP addresses and the exciting solution on the horizon. To understand the current shortage, we must first delve into the history of IP addresses. Imagine it's the early days of the internet, a time of dial-up connections and simple websites. This is the era of the Internet Protocol version 4, or IPv4 for short. IPv4 was the first version of the Internet Protocol to be widely implemented, and it came with a seemingly enormous pool of unique addresses, about 4.3 billion to be exact. At the time, this seemed like an overwhelming amount, a virtual ocean of addresses. I mean, who could possibly need 4.3 billion unique identifiers, right? However, the architects of the internet didn't foresee the explosive growth that was to come. The internet, initially a tool for academics and the military, became a global phenomenon. As more devices connected, each requiring its own unique address, this ocean began to dry up. To make matters worse, early allocation practices were, let's say, a tad wasteful. Large blocks of addresses were handed out like candy at a parade, even when they weren't necessary. So with a rapidly expanding internet and wasteful allocation practices, our vast sea of IP addresses evaporated more quickly than anyone could have predicted. And that's how we ended up in this predicament. But what's the solution? Enter IPv6, the knight in shining armor, ready to save the day. With a seemingly endless amount of unique addresses, IPv6 is here to tackle the issue of the disappearing IP addresses head-on. Imagine a city running out of house numbers. IPv6 is like creating a whole new world, with enough house numbers for every grain of sand on Earth. Now, you might be wondering, why so many? Well, in the digital realm, every device needs its own unique IP address to connect and communicate. And with the explosion of smart devices from phones to fridges, we are in dire need of more digital real estate. This is where IPv6 shines with its mind-boggling capacity. We're talking about a staggering 340 undecillion addresses. That's a number with 36 zeros. With this, we could assign an IP address to every atom on the surface of the Earth and still have some left over. Transitioning to IPv6 isn't just about avoiding a digital drought. It's about preparing for an increasingly interconnected future. It's about ensuring that every device, every person, every service that needs to connect can do so seamlessly. So, in essence, IPv6 is our ticket to ensuring the internet can continue to grow and serve all of us. Let's put it all together now. In the grand scheme of things, IP addresses are the unsung heroes of our connected world. They're like the postal system of the internet, ensuring that every bit of data finds its way home. But our internet's growth has been so explosive that we're running out of these crucial addresses. Picture this. We're in a city that's outgrown its postal codes, and the mail is piling up. That's where we stand with IPv4. Enter IPv6, our saving grace. It's like a new postal system with enough codes for every grain of sand on Earth and then some. It's not simply about accommodating more devices. It's about paving the way for innovation, for things we can't even imagine yet. So remember, transitioning to IPv6 isn't just a tech upgrade, it's a necessity for the continued growth and accessibility of the internet for everyone, everywhere.